Yeah, welcome to the MIPS tutorial part 2. Today we're gonna go over floats and some other comments, and I'm gonna be explaining a few things more. So you already know this part. This is the function that the test Yoshi that we have placed in Castle Grounds executes, and say we wanna make him go upwards slowly but then quicker after about 3 seconds of him just standing there. So what we're going to do is we load from 0154 from T0. This is the timer that each object uses. Like when T0 we already have the Yoshi object. I'm gonna be assuming that you have watched the previous tutorial for this, otherwise you won't be able to keep up with this. Next up, we use the slti command. So what the slti command does is if T2 is smaller than 0x60, set 80 to 1, otherwise set 80 to 0. So since the timer increases by 1 every frame, that's what the timer does. After 60 frames, 80 will be set to 0, and before it will be set to 1. And since we want to wait a bit before the Yoshi moves upwards, we're gonna put a BNE 80 R0 to the end. Actually, let's make a second label. We need that later. Skip 1. Skip 1 is basically the same as end right now. So yeah, before 60 frames, we just go to the end. Now, let's say we want them to only move for around a second. So what we could do then is LTA 80 T2 0080 and then BEQ, because BEQ now 80 is 0 if T2 is bigger or equal to 80. So only while T2 is between 60 and 80 does the code that we were right into this gap get executed. And in this gap we wanna increase Yoshi's Y position, but we wanna start slow and get quicker while these first 20 frames are running through. So what we're gonna do is add U 80 T2 FFA0. So what does this do? FFA0 is a negative number now. If the number is above 8000, then it means this number is negative in our add U comment, because the first bit stands for whether it's positive or negative, basically. A0 is exactly minus 0x60. You can prove that by like this plus FFA0, and if you do this addition, you get 1 0 0 0. Basically, let's say calculate negative numbers. Now we wanna load Yoshi's Y position. We need to do that with an LWC1 command, load word coprocessor 1. Now why do we use this instead of LW? Because Yoshi's Y position is not an integer value, it's a float value. It can be 0.5 for example, which we couldn't do with integer values. We need to use different registers here, because now we use coprocessor 1 registers. We are going to use F2, meaning floating point register 2. 00A4, that's where Yoshi's Y position is from T0, because that's what Yoshi is. Now we have a problem. We can't just add integer and floating point values together, because floating point values work a little differently. For example, 1 is represented as 3F800000, and 2 is represented as 400000, and 4 is blah 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 408000. And for example, you can represent almost all numbers that you will ever regularly use in Mario 64 hacking with just floating points. So if you ever wanna calculate a floating point register, I recommend you use the floating point converter on this website, this one. But we don't need that right now, but we will need that later in the tutorial. So anyway, we need to convert our 80, like we subtracted 60 from here, so that in the first frame that this runs we have 0, and the second one we have 1, the next one we have 2, and so on until we are all the way at 0x20. So that way we slowly make Yoshi go quicker upwards. But now we also need to convert our AT into a floating point register. Now luckily we don't have to do that manually because the N64 has a command built in for that. For that we use mtc1 move to coprocessor 1 AT into F4. Now F4 is what was an AT. Now this is still the regular word representation, so we need to do cvt.s.w f4, meaning convert from word to single point precision float. That's what we use, like that's what the S stands for. F4 into F4. I need to delete these annotations so I can actually assemble the code later. Now F4 is the floating point representation of the number that we've calculated here. Now we want to add .s. We can't use a regular add command, because if we use the regular add command, then for example we knew that 40000000 is 2, and if we added 2 2's together we would get 80000000. But what we really should be getting is 40800000. So we need to use the add.s command. So for that we're gonna do like the regular add command, but this time with a .s because we use floating points. And just like you'd expect, we just start back. Now if we assemble the code, we should see Yoshi move upwards a little for about a second after 3 seconds are over. Let's test it. There we go. Now say you don't want to you don't want to always have to add the value. SM64's engine luckily has something for that. It has speed values rather than just editing the value. So for that, let's not do it like this. Let's get this to end and this to skip 1 so my thing works. So this is after our regular thing went through, right? And we know that he goes with a speed of 32, like 0x20, at the end of this time interval between 60 and 80. So let's say we wanted him to keep moving at the same speed. For that, we know it's at 32 or 31, I don't really care. Let's put 32. We can put this into the floating point converter. We get, this is the number with a bunch of zeros. So we already know how to get a number like that. This Louis 80 and then this, and that automatically fills the zeros in. And we can just store to his y speed this number. And his y speed is at 00b0. And once we've done that, we only need to call the move object function, which always increments Mario's speed, Mario's y position, x position, and z position by his x, y, and z speed, and that is showing on F070. Now if we do this, he will just go through the code one by one. The first 3 seconds, 60 frames, he just always goes to end. Then the frames afterwards, he does not take this branch. Instead, he does all of this. And wait, he also does that. That's not what we want. We want B000. And here, okay. So afterwards, he also does this, which increases his Y position by a little bit, depending on the timer. So it keeps increasing his Y position by more. And then we just go to the end and end this code. Then after 4 seconds, 80 frames, well, roughly 4 seconds, it's a bit more than 4 seconds, we go to skip 1, which stores 32 at his y speed, and this calls the move object function as well. So he will slowly accelerate to 32 speed and then keep moving at 32 speed. So it looks like he's moving smoothly. My planet needs me. There he goes. Now, obviously, if you've been an observant viewer, we don't really need to do this. Instead, we can do it in a few less lines of code. Instead, we just LWC1 F200B0 from T0, because his Y speed is obviously also just a value, it doesn't get reset. And then we can just put 1, like FreeF80, I've explained before, that's 1. And add his Y speed by 1 every frame like that. And we don't really need to go to the end. Actually, yeah, we can't go to the end anymore now because then this function wouldn't get called. And now we should have the exact same result. Oops, I forgot to fix the checksum. Always fix the checksum after you've made the change to the checksum. Otherwise the checksum's invalid and the thing does not boot up. And there he goes. Yeah, that's it for the floating point registers. You now have all the basic instruction for MIPS assembly down. And you only need to, like whenever there's an instruction that you don't know, there will be a few. You can probably just Google it online, find an instruction sheet, and it will be self-explanatory because everything else bases on this kind of stuff. I'll see you in the next tutorial, which will be about debugging.